I'm very pleased to welcome Lev Vaidman for the second time, but this time in reality, because the first time for your speech you were not able to come due to the epidemic, and you just did a video, and now we can hear you in reality, so that's very good. And we are going to hear you to know why MWI is not still or yet the consensus, but it will be soon the case. Is it that? This is what you are going to prove.
Proof? I don't know.
To explain. Thank you, Lev. I'll let you speak.
Okay.
Thank you very much, Lev.
Thank you. It's much more pleasure to be here than to be on Zoom, although I think we all kind of get used to this virtual reality. So essentially the important talk was given last time, and the many words interpretation as the best explanation of the results of experiments. And for me it's the best interpretation. I strongly believe in it, and it's not that I changed my mind and now I give this why it's to say something negative about this, because one reason maybe why it's not in a consensus, because it's not good. I believe it's very good, and there is nothing close to it today, and I even want to believe that this is the final word. Quantum mechanics is the final word, and I believe the only sensible way to understand it is a many-word interpretation. However, there is a kind of fact, at least in the world I live now, it's not in a consensus. Although it's not absolutely clear, when I talk to physicists, some of them, the majority say shut up and calculate, we're not interested. People who are interested, some say yes, there is something wrong with interpretation, but we have to find something new. Among physicists, which I ask them and they do believe in one of the existing one, I think the majority is many words, but maybe it's because I meet the right people. But there's no question that it's not in the consensus. And what I will try to discuss now, and maybe you will help, I will try to understand why it's not in consensus. So, first, for me, this is many words. I put it in a standard that's completed in philosophy. The many-word interpretation of quantum mechanics holds that there are many words which exist in parallel in the same space and time as our own. The existence of other words makes it possible to remove randomness and action at a distance from quantum theory, and thus from all physics. The many-word interpretation provides a solution to the measurement problem of quantum mechanics. And for me, I think this is the best solution. Does interpretation also provide solution? But also this interpretation remove randomness and action at a distance. Some remove randomness but don't action at a distance. And I think this is the only one which removes action at a distance. And I think this is a winning argument, at least for me. There is no consensus. Even now I was trying to talk. People are not fully agree with me that this is the only one which removes action into distance. I believe it's true, but maybe the whole talk I can talk about this, but I will give 2 slides why I think so. So, I want to hope the explanation is the following. I think we are kind of want to be in the center. We are not ready to be, especially people who live in Paris, I think, should feel that we have to be, Paris should be the center of the world. And this picture, I think, provides a good explanation why the many words is not in a consensus. This is not about many words. This is another explanation. Yeah, you understand the picture. And there is this history. This picture was not present long time ago, but even third century BC, people kind of got the idea that maybe Earth is not the center of the universe. But it took a long time. Then it's long time, much later, Copernicus kind of provided a pretty good theory why it is so. But even hundreds years later, Galileo was convicted of heresy for promoting Copernicus' ideas. And only even in 18th century, Copernican view was almost universally accepted. And this is not, we have like 2,000 years to get this idea, which was existed and was not accepted. Copernicus removed Earth from the center of the universe, and people are not happy. Whatever he did, he removed Earth together with Sun and together with all our reality from the center, and people don't like it. So I believe that it's not in the it's not in the consensus yet. We have to it's a new. We have to get used to it because this, I believe, is the truth. So, again, now if I go to talk to physicists, most of them say standard quantum mechanics works. Why do I have to believe in science fiction? I go to philosophers. They go and say physicists didn't show us experiment which many words definitely must be there. So why should I adopt this bizarre option? Maybe I have some examples. Tony Leggett, I was trying to invite him to a many word conference, and this is what he wrote to me. In my view, the many word is not wrong, it is simply meaningless. In the abstract of the article Many Words in the Standard Encyclopedia, which I presented, it is stated that the letter holds that there are many words which exist in parallel at the same space and time as our own. He added emphasis. Other formulation hold that the unobserved words are equally real to the one we think we observe. My question, what do the emphasized words in the above quotes, ostensibly English, actually mean? To me, they are as meaningful as Chomsky's famous non-sentence sentence, coral is green, ideas sleep furious. So, here in Standard Philosophy Encyclopedia, there are two entries on many words. There is my entry on many words, and there is another one on Everett, which for me is many words. When they commissioned it, I asked them why they do this. I don't know, but I didn't press too hard because I did want to have my entry in. And maybe the reason, because from the beginning I fight with SCP, they say that I'm biased, because I'm for 30 years believe that many words is by far the best interpretation. And I couldn't write an entry on many words, and it was different tone. The other one has different tone. So he wrote, this is from entry on Everett in Standard Philosophy Encyclopedia. Insofar as Everett's standard of empirical faithfulness just involved finding measurement records associated with a modeled observer in the theories that agree with one's experience. It is relatively weak variety of empirical adequacy. So he kind of says that we don't have real evidence for many words, so why should we take this? So let's start with a list of objections which I consider naive, although they still, maybe they're not so naive. They look naive for me, but maybe not for others. So one, the very naive, why we do not see the parallel words? We see one word. many, in fact, physicists, when I talk to them about many words, but they say, where is the energy? You split the words, the energy should be twice. What's happened with the mass? For these 30 years when I look, at least before, there were kind of two main objections, and one was preferred basis problem. For me, it's still kind of naive, and I thought that it was forgotten, but it looks like it was not. People attack me and ask me, you talk many words, tell me exactly when the words split. And when I cannot, they reject it. Frequently, there are papers, and maybe I'll give some examples. There are too many words. There is kind of many people, and some serious people say that the Born rule inconsistent with word counting. So it cannot be true. We have a kind of empirical evidence that many word doesn't work. There is persistent idea that if you believe in many words, you should use quantum Russian roulette because you're immortal. So let's look on some of these objections. Preferred basis problem. When I have cat alive and cat dead or lying, if you want to be sleeping, then it's kind of stable, it's clear, kind of nice basis, and this is what usually used when people talk about many words. But if you look at mathematical description, you can have another basis on equal footing. Why not to use plus basis and minus basis? The plus is when you have superposition with a sign plus of alive and dead, and minus when it's superposition alive at minus dead. I thought that it's clear the stability of these words, which are alive. If I get alive, it's continuing to be alive, at least until maybe the next decade. And if it's dead, then he will remain dead. But the plus, like Zurich made some calculation, we have to wait 10 to the minus 40 seconds, and then plus will be mixed with equal weight of minus. So we don't. So I think this argument is very strong, but still, the paper, Synthesis 2022, the preferred basis problem in the many-word interpretation of quantum mechanics, why the coherence doesn't solve it. There are too many words. I think, I believe one of the reasons why many words is not, it's hard to blame. I want to blame DeWitt, but maybe I shouldn't, because without DeWitt, many words was kind of forgotten, and he brought it. There was a book, which this book made big impact, and people started talking about Everett theory. But I think he ruined many words, because he kind of really saying that many words are really, this is his writing, every quantum transition taking place in every star, in every galaxy, in every remote corner of the universe, is splitting our local world on Earth into myriad copies of itself. So I think this is very problematic sentence. It's very imprecise, and the whole idea of DeWitt. For DeWitt, when you split, you cannot, in principle, bring branches together, bring words together. But he was powerful enough. Wheeler was kind of he was advisor of Everett, but he backed up from support. I think mostly because Everett was not successful to persuade Bohr. When he sent, Wheeler sent Everett to Bohr, and this didn't work. And so Wheeler said, I have reluctantly had to give up my support of that point of view at the end, because I'm afraid it carries too great a load of metaphysical baggage. So this was too many words, and we also have also from Hilary Putnam. Hilary Putnam wrote a paper about and considered also the option of many words, and was very much against it. And so the one argument is that he kind of considered as the experiment. His experiment was that Einstein enters the room and look on his bed. And I don't know if citation is correct or not, but Hilary Putnam said that Einstein said to somebody that before he thought that before he entered the room, the bed was spread out, and only his entering kind of fixed the bed in particular corner. So then he said if he will do it 30 times, it's not clear why it's better. I don't think it will split, but maybe he considered as an experiment that will have many different histories. And so he wrote, I repeat, on the many word interpretations there will be 2 to the 30 Einstein histories, parallel words. Science fiction is literally right. I think I was a little surprised. This was 2005, but he kind of strongly accepted this idea that we have to count words and get probability out of it, and when it doesn't work, the many words collapse. And then he considered this kind of if I perform like spin experiment with unequal weights, and so we have a count number of branches that we'll see that there will be very many branches in which the observers believe in something which is incorrect. And so and the observation of most observers will disconfirm the theory, and he's not the only one. Gene Bridgmont, he's so strongly believing in bombs that he cannot see anything else, but his objection is naive to many words. The same, he says, many of our descendants will not observe Born's rule in their words. He considered the experiment which you had this unequal weights, and essentially the same experiment. Quantum Russian roulette. There are in many places I entered, but what I was really surprised, in Wikipedia they have this entry. It's very long. This is it's not something particularly interesting there. How much this is all about one thing, that if you perform quantum Russian roulette, that you remain alive. This is what they say. It's kind of quantum suicide is a thought experiment in quantum mechanics, and immortality. They say that it's a good idea, and they consider a real experiment that we have to perform, that if you use it and you remain alive, then you should believe in many words, which is, I think, really ridiculous. There is no observable difference between collapse theory and the many words theory. No. Only if you have super technology and you can bring grand branches together, which is completely unthinkable, it might be different. In any other case, it's the same. It's the same observational. We have the same evidence. The only reason why I'm so strongly believe in many words, because I have physics nice. I don't have randomness, and I don't have action to distance, and my equations are economical. I cannot prove it by any other means. And so all these attempts, quantum Russian roulette is really kind of for me. And there are papers, okay. So what are more profound, from my point of view, objections? Again, this is not objections, but but it's kind of reason why people don't, why it's not in the consensus. There are proponents of many words, strong proponents, which make some claims, which make them very strongly. Even Everett himself kind of said that that probability can come out of formalism itself. I'm not sure it's written very kind of black and white, but it's more or less appears there. And then Deutsch put it strongly, and Wallace claimed to clean it very much, and David Deutsch agrees, continue to agree. But there are like tens of people who says it's circular, or some others, and I think this make a big damage to many words. All interpretation postulate Born rule. There is no one interpretation which you can derive Born rules. There are all kind of, even Aronov was claimed that from weak measurement you can derive or something like this, but really, essentially all interpretations, at least if we talk about interpretation, have a Born rule. So if many words cannot derive a Born rule, it doesn't kill many words. And so the fact that you say it solves something and it doesn't, then it's not helpful. Then there is this kind of feeling, and the emergent classical words. I will have this picture of Wallace books which talk about this. Another, there's too many word interpretations. This is really, if I believe a many word is correct, but again, that maybe I'm also guilty. I believe my many word interpretation is correct. And there are many other called the same many word interpretation. For me, they are almost orthogonal. I think they make claims which I think you cannot make claim in the framework of many words. So there are two, so there are many word interpretation, and all this, it's still small minority. How people will believe in many words when the proponents disagree with each other.
Can you just give an instance of that, of diverging many words interpretation? Or is it just one?
The main thing is that people want, there are you say diverging, there is diverging and overlapping. Diverging is not many word, it's many word interpretation, but of no interest from my point of view. And there are many serious people who want diverging many word interpretation. But they say that now all these words exist. And they're trying to say that it's numerically equal or some other things, words which I never understood or what it means. That now when they will be splitting later, that before splitting, with these two words are already distinct, but they kind of numerically equal. I cannot make sense. I say it's maybe like many minds of Albert or something else. So this is maybe one example. Another, maybe not so big, but this many interacting words. That's kind of a new story, which is really kind of Bohmian, many Bohmian. Has nothing to do with many words. Or the Deutsch Haydn, which I will talk about it. Which the Deutsch, in fact, he is one of the strongest proponents, but he also has all kind of versions of many words, which for me do not look like many words.
And so will you answer this objection?
What?
Will you answer this objection that the many worders disagree between themselves? Each one is on word?
So, I was in many word 50 in Oxford. I couldn't go to Perimeter because it was during Yom Kippur. And I organized now many word conference myself. There was on shoulders of Everett. So I've been in all these conferences. In these conferences, in the last one which I organized, there is no consensus what many word is.
So it's a problem, no?
It's a problem.
Yes.
It is a problem. And
okay, so you consider it's a problem. That's it. Okay. No, my question was whether you would answer this problem, but no, you just sort of acknowledge it is a problem.
I don't know, maybe I'm politically incorrect, but I will say the following. I'm working in foundations all my life. I started with Aronov, and my feeling is that when you work in foundations and I'm going to all these conferences, 90% of people work in foundations thinks that 90% of other people do is bullshit. This is fact. So clearly, it must be that many of them mistaken.
It's sort of the steady state of the process.
This is, again, I'm one of them. So, but in the end, again, some people, I remember I met Squires when he was a long time ago. He's not with us for many years. And I said that you wrote this nice paper on many words, and now I don't remember what it was. It was another paper which was completely contradictory. Explain to me. So what to explain? I found interesting things there. I wrote something. I found interesting things there. I wrote something. I learned many words from David Albert in Tel Aviv long time ago. Dave Albert doesn't believe in many words anymore. I remained there. I found it that this is the right thing, and I still have hope that it can be changed. This is why I spent a lot of time and effort on my conference in Tel Aviv, and I want to continue. So I'm also come here. But for this, I really need answer to this, why it's not in the consensus. I believe it takes time, but if people will work on it, maybe it will come faster. I think it's important that it will come faster. Maybe, again, I'm trying to say that if somebody will show me where it's wrong, it also will give me a solution. I would not like it, and maybe I will not be able to understand it. I don't know. I admit it. In some cases I made mistake. And what I found from philosophers, that what I think necessary to understand many words, we have formalism, and we have experience, and of course it's very important to connect the formalism with experience. Philosophers tell me if the formalism is the right one, it is immediate. You don't have to make additional postulate. I say there is a formulate, and then there is this additional intermediate part which make connection. And maybe I will return to it later. I think so. This is one of the things why philosophers hardly accept many words. I give them formalism. You don't see what we see around. You have to make a very careful, specific postulate or kind of part of the theory. What is the connection between the formalism and the experience? And some philosophers says, no, this is come to me with a new theory when you will not need it, and then I'll talk to you. This was even especially happened in the last conference, and Simon Sanders was telling me this, that without their chronic personal identity, no one will accept the theory. I say, I cannot ask what will happen to me. This question is illegitimate. And he said, if you continue to say it's illegitimate, forget about persuading people. People want to know what will happen to them. If the theory tells us, you cannot ask this question, there is no word line of me. I say there is a word line of me, only backward in time, not forward. There is no meaning for this. And so then there is the issue of non-locality. For me, on one side there is this great thing that I believe, this is why I believe in it, that on the level of the universe there is no action at a distance. Still, on the level of a world there is no locality. And even people who believe in many worlds, they want to solve this locality problem completely. And I don't think that many worlds solve it. Non-separability is still there. People want to... So we don't have a consensus because people are unhappy about these things. So let me touch on some of this. Proponents of many world promises that may remain highly controversial. One, it's this Everett Deutsch Wallace, quantum theory of probability and decision. And there was a lot of literature on the subject. And the literature goes both ways. I'm a little, I was trying to persuade David Wallace that, David, you have this, had several papers defending Deutsch. Then there are like 10 papers attacking you. You are silent. He said he is not interested. He goes to a field theory.
Why are you putting Everett here? Do you think that Everett himself wanted to derive the Born rule?
It's in one of the writing I saw something of the kind.
There's something on this?
Yeah, there is kind of. He didn't put it very strongly, but
in his thesis, in fact.
What?
In the thesis, he
Yes,
wrote.
yes, yeah.
He wanted to derive the Born rule?
Yes.
Okay,
Yeah.
I didn't know that.
Again, it's not. I have my own derivation. There are many derivations in all these.
But do you agree with them? No, you disagree with them.
I think
Not good level.
for many years my position was, look, every other interpretation has a postulate, so we don't need it. We don't. Now lately my position slightly changed even it became stronger. I say it wasn't clear for me if it's possible, not possible. I think it is unitary evolution alone is not enough. You must postulate something.
Yeah.
Now, I have some postulate and don't send signals faster than light plus symmetry, and this give you a Born rule. Some other, you have to add some postulate, but the important point is that without postulate, it doesn't follow from unitary evolution. Because I found the example, you can do unitary evolution and you have another postulate, which technically is consistent with everything. Consistent with unitary evolution, inconsistent of course with empirical evidence. One can say we go to our book and laboratory and we see that the Born rule works. But this is not the proof. From unitary evolution it doesn't follow. It's additional postulate. Some people say Gleason's theorem. No, the same story. In Gleason's theorem there is additional postulate that one thing doesn't depend on the other. So you cannot derive it. Now for example, even here it's written that together with non-probabilistic part of classical decision theory. I was trying to take from David Wallace what exactly you take from there, and it wasn't. I didn't. I think the main thing, which is, it's enough. If you're in a branch, and you believe that your probability to be in this branch is such and such. Now you split this branch in two. Then the probability to be in all these two branches is equal to the probability of being in the first branch. This is enough to prove the Born rule, but this is a postulate. It doesn't follow from unitary evolution. What?
But if you do this, then of course the way Everett interpretation is introduced in introductory courses is always people saying there are two types of evolution and we want to get rid of the collapse, so we just want to keep unitary, and this is what Everett achieves.
Yeah.
So this is a sort of standard textbook story. Now you're saying that standard textbook story is not serious.
Why?
Because you cannot just keep unitary evolution and have the Everett interpretation. You still have to add the Born rule or any other equivalent postulate.
Yes, because it's textbook, the standard one, where you have one outcome, you have collapse, and then it's natural to say what is the probability of collapse. In Everett, there is no collapse, so it looks like you cannot put the postulate. So this is why you expect that maybe unitary evolution is enough. I believe it's still not. There are, but I think my contribution to this, I not necessarily talk about this. So there is a situation in which you know everything, and if you know everything, you expect that there are no questions for you. But you might know everything, and you still be in probabilistic situation. If I perform quantum experiment, and I move to do different places, and I don't know who am I. I know the wave function of the universe, which says, oh, there is me in one room and there is me in another room. But if my local environment is the same, I don't know in which room am I. If this room have different amplitudes, now I have a way to add postulate. Probability for me to find myself in particular room, who am I, is such and such. So, and this is additional thing, and this is, if you this way, it's an additional story. Again, I think it's make many words a little less powerful. Well, I didn't thought enough about this before. I thought in unitary evolution, the whole story. It has to be supplemented to explain it's to explain our experience. If I want to talk about kind of what is the wave function, it doesn't care who am I and whatever. It doesn't have cannot pose this question. So if the shapes of people and me move everywhere, but if I want to ask a question, what is probability to me to find myself somewhere, I have to add a postulate.
In your position, and that's coherent, you have this postulate and you say, okay, this is something more than the simple unitary evolution.
Yeah.
I add this postulate and then that becomes coherent and there is nothing to say. It's okay with that. And the difference between your position and Wallace's position is that he tried with Saunders and the others and Deutsch to deduce what you postulate. And trying that, to my mind, they say very strange things because they mixed things that have nothing to do with physics, and they reintroduce the will of the observer and things like that with decision theory, which has, to my mind, nothing to do with the problem, and that was totally unsuccessful. I largely prefer the fact, as you do, to say, okay, we have no way other than to postulate something special, and once that is postulated, that becomes coherent, and Wallace was not coherent.
So, usually I always ask for disagreement, but agreements are welcome. Because, just this postulate is not completely out of the blue, it's natural postulate. I have to say that if I have kind of all words which are more or less equal, then I use standard probability kind of combinatoric ideas. If I arrange that all my different words have equal weights, then probability to find myself in every word is the same. This is very natural. But again, it's a natural postulate, but it's like postulate that if I perform unitary evolution in one of the words, the probability to be in this word doesn't change. Now I can take all these words, make unitary evolution in all of them, so they all will be essentially the same. If they're all the same, I believe in symmetry. The probability cannot be different. So it's not, first, you have to add postulate, but it's not very strong postulate. There are very minimal thing which you postulate, and then it must be Born rule. This David Wallace's book has the emergent multiverse, and I've been in, I think maybe at least in one conferences maybe in 2. There is this emergent in Vienna, or it was nice. The program is to find classical word out of quantum word. And especially this kind of Oxford school, the coherence give us this. If I have experimental situation, I prepare a quantum experiment, I perform it. I understand my splitting very well. If I'll take kind of arbitrary quantum state of the universe, to get out of this from the coherence, many parallel worlds, I think it's extremely difficult, and I'm not sure it's necessarily impossible, but I even don't know if the weight of these branches with words like we see will be very big. Maybe most of the words are really kind of like complete chaos, and only some of them look here. I think if you look on the whole together, to get the emergence of words, it's very difficult. And I think some of them say that it succeeds, not succeed. Clearly, there is no consensus that this program was successful. And again, this is what makes people not to accept many words. Many worders say, oh, we have this idea and now we'll get everything. But it doesn't work well, at least not work clearly. So let's talk a little more about emergent classical words. So this is kind of a picture. For me, every word, some macroscopic objects are macroscopically different. And maybe I also have the word here. We are now here. I say that when we have everything, it's very difficult. We have this wave function of the universe. Somebody came to us and wrote this big wave function. He didn't wrote it in the right basis. He just wrote it. To find this will be very difficult. Now, and all this wave function, people look on wave function and very upset. For me, many words is to say the wave function is the whole story. Psi is all. I have one of the papers. But Bell considered like a prophet, and what he said, no one's supposed to go against him. And so this is quoted many times. Either the wave function is given by Schrödinger equation is not everything, or it is not right. And this is influenced many people on foundations. If Bell said we should. Tim Maudlin is kind of serious, taught a lot of quantum mechanics, and he's very upset that formally, or at least the wave function is in configuration space. Dave Albert added to this that, it's in configuration space, this is how it should be. And but Tim says, we live in 3D. How can you explain table or myself in configuration space? Again. And many things that wave function, it's mathematics. Like Gene Bridgman again, wave function, but that is just a mathematical object. This is your quotation. The wave function, the state vector, is only mathematical tool.
To calculate probabilities.
To calculate probabilities, yes, which I don't have. So, people really want 3D. Bohm gave them. This is kind of Bowman particles. We can see a cat. It's made out of Bowman particles. GRW. Philip Peirce started it and GRW continued it. This was about wave function. They had wave function, but the wave function of many words is very difficult to connect to reality. A single collapsed wave function, this is really textbook. What textbook says? There is a wave function. It's only on every measurement it collapses. The collapsed wave function of this room looks very much like this room. But lately, this is not popular, and this is because the wave function, even collapsed wave function, atoms here in configuration space and whatever, they want 3D. And even the GRW now is spoiled. There are flashes. Flashes are like Bowman positions. Like then 3D, they really live in 3D, the GRW flashes. They also have this mass density, which is, I think it's not at anything, but also kind of mass density in 3D. It's again started with Bell to blame, with his local bureaus. So there is this whole school that things have to be, that it should be kind of primitive ontology. Like this is Valéa Laureate. She's part of this program. Even to consider Bowman mechanics, that in Bowman mechanics there is a wave function. It's part of the ontology. I don't know how you can live without this. But Bowman says, no, this is, if you consider it part of the ontology, then philosophers will not be happy. Why are they not happy? Because we need axiom. I believe that Bowman story is sensible when you add axiom of experience. Your experience only Bowman position. Ontology has a wave function, but you experience Bowman position. So they don't want the axiom, but they kind of have this axiom by saying that the wave function has a nomological character. It's a law. For me, it's too complicated law. Law should be simple. You have to put it on a t-shirt. And their law, it's a wave function. You cannot put the wave function of the universe on a t-shirt. There is not enough Hilbert space. So, and in the primitive ontology, the one which corrected to experience, must be local. So this is, philosophers don't want some connections. They want, if a theory will get a picture. And it was before, if everything made out of atoms, a table made out of atoms, we see the atom, we see the table, if it's classical atom. But if it's kind of wave function in configuration space, it's hard to see this table. Maybe a little I want to say. So if I look at the whole wave function and I'm not given this structure, I think it's not easy at all to see the structure. If I live in a particular branch here and I perform quantum experiment, it's easy for me to calculate, to understand what branches will happen. So I think the many words, I have to explain my experience. I live in a particular world and I have information about what is happening here. This information is good enough to say what will happen later in my branch. Maybe if I have some memory about this experiment, I know there are some parallel branches which are not there. And this is tractable. This kind of calculation I can do. Somebody give me the whole story, find the structure is difficult. Because, yes, but I'm here, and I have the past in my memory, and I have splitting later, but I can understand what it might be. Non-locality. For me, kind of obvious, but even today we was writing here and I was failing to have this example. I want to repeat it. I believe that if you accept one word, you must accept action to distance. If you accept quantum mechanics, because we know that if you have an EPR pair, then here we have an EPR pair. I have one electron sitting here, in this box, and another electron is on the moon. I say this other electron now, if it's an EPR pair, it has a kind of real physical property, it's unpolarized. If I know that 1 minute from now somebody will measure spin up and down, then I'm ready to pay, ready to pay 10 cents for a game. That if here will be found up, later there will be sent message from there, it will know that it's up, then I will get...
You told me that, so if you do that, the electron on the moon is not unpolarized, it is part of an entangled pair, and it's completely different.
Well, wait, let me state the example and then we see how the objection. So, the story is following. I prepared, let's assume, 1 electron here, 1 electron on the moon, and then EPR. It's, today it's still, it's not absolute science fiction. It's not Wigner friend. So we don't have this experiment yet, but if Chinese send some kind of entanglement to satellite, moon, 10 years from now, 20, this will happen. So, or like Harald Weinberger with all these atoms, which are, they made this good EPR pair by photons and whatever. So this is feasible to have an EPR pair between here and the moon. So, and then somebody, you see, when I don't open it, so I don't know I don't make any measurement on my electron. The other electron is unpolarized. It has probability half for every direction, and particularly for going up Z or down Z.
You contradict yourself. You just told this electron was part of an EPR pair.
Yes.
If it is part of an EPR pair, this is a fact. This is a fact that it is part of. You cannot tell now. Okay, it's unpolarized.
It's unpolarized.
It is
not polarized.
Yes.
Unpolarized. The
Yeah,
meaning, the meaning of this.
Just a question of what he means is that you have a half probability to find it in any direction. That's what he means by unpolarized. That's not the right term, but that's what he means.
This is the point, because whatever you do must take into account also that it is part of the EPR pair. Okay, but there is no question. There is no question that everybody.
It's just that he can measure it with a half probability for each direction and each value. That's what he means. So the term unpolarized is probably non-appropriate, but it's not important for his argument in this case.
What?
In fact, it is unpolarized.
What?
It is unpolarized if it is in an EPR pair.
Yeah.
This is what I said.
Yeah.
I think this is standard.
This is not a problem.
What? But even semantics, no question that everyone should agree to play a game. That a measurement will be performed here, and €1, $1 will be given to you if it's up, and $0 if it's down, and you pay only 10 cents. This is everyone agree, and clearly this is about measurement here, so this is about something here on moon. Now, the point is that so everyone agrees, so the property here, this is a property, there is something which is ready about experiment here, so this is a property here. Now, after I measure, now I do this, and I offer you to play. It will be crazy for any of you to play, because why I will offer to play when I will not offer you to play if I'm losing. So now you shouldn't play. And this happened much faster than 1 second. I just opened, you saw that I saw the other one. So now you are not ready. So clearly something changed there. If there is only one word, something changed there.
Excuse me.
Yes.
What you say is based on many underlying assumptions about what a measurement is. Your reasonement is right only if you assume the standard realist position where systems have properties by themselves, and then when you make a measurement somewhere, the result is absolute and shared with any other observers. In this case, you're right. But the interpretation, and there are many that don't rely on these assumptions, cannot follow you, because you can present that in many other ways. And what you assume here, without saying it, but it's right, but you have to explicit your assumption, is that you are in a standard realist framework where everything happens as if happens in here. I take this glass, it's here, okay. But that is exactly what is in question in many interpretations, and I can quote many others, where there is no non-locality, while there is only one word. And I know that you don't like it, but I can quote only cubism, relational interpretation, my convivial solipsism, and in this case you have non-locality. So your reasoning is not good just because the assumptions, the underlying assumptions about the realism of the measurement are not taken into account.
There's a whole idea that it seems to me that this example is universal. It's operational. I don't know what I say. First, I want to say that here there is an object, and this object has some property. What's the property? I'm ready to bet on it. If this property will change, so something changed here. Never mind cubism, whatever. There is no any.
That's a very important assumption.
Now, there is one important thing that I say that, but this is kind of most interpretation. Again, in this situation, I have to say that when I know everything, I'm still ready to bet. Before the measurement, the idea is that essentially the quantum mechanics is a whole story. In Bohmian, there is also Bohmian position. So of course the outcome is already given. What will happen? It's already known. The point is that Bohm has axioms that you are not supposed to know this Bohmian position. But if in cubism, whatever, I don't know, whatever, they don't want to talk about reality, it's only about meaning.
May I add something else? Yeah. Okay, so I try something else. So you have your two particles, one here and one here, and you have this entangled state. What the entangled state says is that if you make a measurement here and a measurement here with different angles, the probability of plus plus, for instance, will be the cosine square of the angles. Okay, we all agree with this. This is what your test says. Then, if you ignore what is here, then you get randomness on the other side. And that's it. So now you don't bet anymore. Because you know that.
One thing before.
It just means conditional to the ignorance on one side.
But
and then.
Even you have conditional. Now there is no condition. You don't do anything on this. Just ask what is the probability here.
If you tell that, then you ignore the nature of your EPR pair. The EPR pair, what the EPR pair tells you is that the probability of plus plus is the cosine square of So if you know that, you don't bet anymore, because you know that if the other guy makes a measurement and knows the result, he knows the result. So you don't have to bet. So it's not if you see only one side, you see a non-polarized photon, I agree, but what the EPR pair tells you is that there is a correlation, and so then you don't bet anymore because the other guy knows the result. So
before measurement.
So you are cheating.
Yeah, you agree with me that there is a kind of property of this object.
This is the whole point. There is an EPR pair. An EPR pair is a property of a pair of photons. So you just exploit this property to tell that there is a correlation. And then if you ignore one side, then you will randomness on the other side. But your state does not tell that at all. Your state tells there are correlation between the measurements. So, this is the basic point.
I'm talking about action at a distance. When I'm talking about action at a distance, I have to accept the idea that there are some local properties. Without accepting, if you say, there are some non-local properties, non-local property can be changed non-locally. Now we are talking about local properties. So I ask, what are local property of this object?
Sorry, do you mean local properties before the measurement or after the measurement?
That's the whole point. This local property changed immediately during this measurement, and which was far away. So local property before and different.
I thought that the measurement was made on the moon.
No.
Sorry. So could you repeat the protocol, because
The protocol is here on the moon. There is this electron, and we bet again there will be a measurement on a game.
But
shortly after.
who is betting? Who is doing the measurement? And
We
where?
are here,
Yeah.
not on the moon,
Yeah,
and we are betting
Yeah.
all about the result of measurement,
Okay.
which
We
will
are
happen
here.
there.
We are doing a measurement here, and we are betting on the measurement on the moon.
Correct.
Okay. So what you say is that before I make any measurement here,
Yes.
I'm ready to bet
Yeah.
10 cents to get $1
Yeah.
if the result after on the moon is
Correct.
up. Okay? And what you say is that after I have made the measurement here, I know the result.
Yeah.
Then I am not ready to pay because I know the result.
Somebody against me will not be ready to pay because I know the result. Betting against me, I offer you a game.
Against you, so
I offer you a game now, and you see that I didn't touch it. So you have to agree with me. But now you disagree with me. But this disagreement about something far away.
But assume that you find up. Okay. What is betting against you? What do you mean? I don't understand what that means. To bet against you in this case, I don't understand the protocol.
This is a game that
No,
you give me 10 cents and you get €1 and get zero on this measure.
But if you know the result,
Then you will not play with me. Correct.
and I don't know anything myself because I don't know the result.
Yeah,
Okay.
but
So for me,
Yeah.
the result is still uncertain. You're right.
no, but you know that I know. You know this.
I know that you know, but I don't know.
This is
and the result
change.
is half-half.
You know this famous tale about unfaithful wives and what information you get until how long. This is when you know that I know, and things change. This is the whole story. Before you know that no one knows, including me, what will be the outcome here. So this is unpolarized, probability half for both cases. Now, situation changed. Now you know that I know what will be there. So things changed. Before it was uncertain,
I don't know.
and now it is certain. If there is one word.
Do you agree that even if you got a result, if I don't know the result, for me,
Yeah.
the probability is still half-half?
No, because
I don't know the result. So that
no. I offer when it's closed. You know, it's half-half. Whatever happened, but because no one knows.
No
This
one
is
knows.
in nature. It's really half-half given by nature. It's unpolarized.
Yeah.
Now situation changed.
But it's half-half still, but not in nature, but because of my ignorance.
But
it's
No, but
still
there's a
half-half.
preferred basis now.
But in the moment you are ignorant, but somebody might be not ignorant, so you will not play. You play when it's probability half, genuine probability half. There is a good reason for you to play. The expectation value here is €0.5. But now you don't know there is a really euro or €0. You just don't know it. When it's closed, it's €0.5. Really €0.5, real €0.5.
That after I still have euros.
No.
If you throw a dice, if you throw a dice.
No. After this, it is 0-1 or 0 which you don't know. This is different when it exists or it's unknown.
This depends on the information that observer has, but you don't want to speak that much.
About what
About the basis.
Alors si c'est ça, il doit le dire.
What do you mean?
If that guy who's on the moon knows the basis on which the measurement was
No,
made.
here we don't. The basis is that place. We don't
Je veux pas jouer, là, je me dis, il y a un truc qui va pas.
the same basis. There is no.
Pas.
I need this bell, whatever, that there is no hidden variable in principle, but again, for bombs there is hidden variable, so it's non-local hidden variable, but again, but the non-local hidden variable is action at a distance. In bomb you can make action at a distance.
Back, what Philippe was saying is that The problem is with the knowledge of when you use pronouns we, I, etc.
Yes.
The question is who is that we or I, and what kind of knowledge they must assume. So if you talk about this in the language of Bob on the moon, which is not your language, you haven't said that. I'm just saying. If you talk about this in the language of Bob on the moon and Alice on the left and God who knows all these things, then you can say Bob has no knowledge of any EPR pair. He has never been informed that this is a EPR pair. So for Bob, it's 1/2 until he gets some other information from Alice about the basis or whatever. But if your pronouns I or we are always from the God point of view, then Philippe says you cannot, and this is Philippe's contextual interpretation, you can say you can never ignore the context, because from God's point of view, you in CSM, you always know that this is an EPR pair and you can't forget that. So from God's point of view, the information about 1/2 on the moon is incomplete. It comes always in the context of this being an EPR pair, which you can never forget. But this is only true if you reason always from God's point of view, not from Bob's point of view.
So first,
is that correct?
Yes, it's good. Also, what I can tell is that when you claim that Bob, the photon is unpolarized, actually you implicitly assume that you know that it is an EPR pair.
Yeah, you know. I know. I
If
prepare
I
it.
know that it is an EPR pair.
Yes.
Bob knows that this
Yes.
PET photon is correlated
Yes,
with
yes,
another one.
yes.
So
This
he
is-
doesn't bet anything.
This is a story. I prepare it. I found the.
There is no action.
You know, I found the grant and sent and got enough money, sent the satellite and prepared an EPR pair with a moon. I know this.
Yes, so
I know also that in particular in
So what is
1 minute
the-
from now there will be automatic measurement here in the direction. And so and then and now
Then
what?
I'm lost to that. Nobody will bet if you will never bet on the moon if you know that the result can be obtained on the ground.
No, but you see, you look on me, you know that the other particle is here. You see? And if I don't open it, then you'll bet with me. If I don't open it, it's still an EPR. In the moment of measurement here, it will be an EPR.
But that's
So-
that's part of the quantum state. The other box not being open
Yes.
is information that is part of the
Sure. This is the whole point. And this action changed immediately the situation there. Before it was an EPR, and now it's not.
No.
Now it's not. What do you mean? What now? In which you agree with me that, but this is in a closed box, and there is an electron, and now it's an EPR. Now let's say we have technology to keep
If you
it.
start speaking about an EPR pair, so EPR tells you about the correlation. Now,
No.
if you decide to ignore the correlation on one side, it seems that you don't know, but you deliberately don't know.
If you don't measure,
No, yeah, this is
If you don't measure
like
the first pair, there's
in
no
this
correlation,
Bell,
so-
the Nobel Prize was done for mainly for this experiment with atoms. So we have these photons, spent a lot of time sending and in the right thing bringing them, and now they're in EPR state. And they were kind of in EPR
I
state.
don't contest the EPR state, clearly.
What?
I have nothing against the EPR state.
Yes.
What I said is that you deduce this, what you call, I don't know, the non-locality in a single universe or whatever. No, I don't think it's the only interpretation of the EPR correlation. There are several ways to interpret correlations, and there are other ones where there is no non-locality. That is, you avoid non-locality by going to many words. This was your main claim, if I understand correctly. But your main claim is, in a single universe, you absolutely need non-locality.
Action at a distance.
Action at a distance.
Yes.
You absolutely,
What?
it's even stronger. Okay.
Yes.
In a single world universe, you absolutely need action at a distance.
Yes.
I completely disagree with that.
But again,
Same.
may
I
I?
completely disagree with that.
What?
I completely disagree with the need
So
for
how
action
can
at
you-
a distance.
So please.
You have correlations, but you have no action at a distance.
So please again, will you agree with me that when you have an EPR pair and let it stable, these two atoms live forever, Do you saying you agree that EPR pair can live for a long time? Yes.
Yes. Of
So,
course.
so when you have an EPR pair, do you have a local description on the moon? There is such a thing like complete local description on the moon.
Yes.
There is.
No.
What?
From the beginning, you have two
For Philippe, no.
What?
two faraway detectors, one on the moon and one on the Earth,
No.
and that's
No, it's still now. I don't have detectors. I just have the.
Okay.
Yeah.
I come from quantum field theory.
Yeah.
Quantum field theory is a perfectly local theory. There is no non-locality in quantum mechanics.
But that's a different.
But just
No. I think Lev, on the CSM interpretation, which Philippe is talking about, there are no individuals in the EPR pair. You have to. It's a pair.
It's a pair.
Which is an object. It's not made of two individual particles. And if you say that, then Philippe will deny that there is a local description on the moon. So you have to deny this.
The context is that you have two detectors, one on the moon and one on the Earth, and this is the reason why you seem to have non-local action. But it's not.
I think that we are not going to agree just because this discussion is. We need for the discussion to explicit what we mean by each word. When you say that the system has a property that has a meaning that is perfectly understandable in the standard realist interpretation, that is contested by other interpretation, and depending on the meaning of the word, you can say that there is some action at a distance or not, and that's all the debate between all these interpretations which use the same word with different meanings. What you do here is just that you use the usual meaning of the standard realist interpretation where systems have properties by themselves, independently of any observer. If you do that, it was what Einstein supposed when he wrote the article. In this case, you can effectively say, okay, it seems like there is an action at a distance. But there are many different ways to describe the same experiment, and depending on the assumptions that you take, you don't reach the same conclusions. But if we don't explicit the assumptions that we rely on, I think that it's not possible to understand ourselves, and that's the reason why nobody is agreeing.
I don't know of any interpretation which tries to explain the correlation without having some non-locality. You have many interpretations that just put things under the rug, and they just don't want to say anything about the dynamics. That's the meaning of the
I think
interpretation that are local.
No, they don't explain.
Yes.
It doesn't explain anything. It's paraphrased.
So, I may just one more attempt.
It depends on what you mean by the result is this.
I cannot talk about action at a distance without a concept of local property. There is no such. I need to talk about local properties, and I think it's really the fact that there is some object here on which we're ready to bet in particular way, and when we know everything. Well, we know exactly we're prepared, we send. So I think we can talk about, it's a local measurement. So it's a local property. Our readiness to pay some money on a local experiment, it's a local property.
Okay. Can I ask you a question?
Yes.
What do you think of the possibility that the property is relative and not absolute? There are many interpretations where the property is not an absolute property, but it's something that is relative to something. That could be the agent, the observer, the context, everything what you want. But the property is not absolute. What do you think of that? Because if you don't agree because you don't like it, but if you accept this assumption, then you cannot say what you say. I don't say that you have to agree with that. Again, it's a possibility.
Yeah,
Relative property.
Well, again, maybe I'm too simple-minded, but I want to understand nature. So I have 3D. I don't play with it. There is 3 dimension, in this 3 dimension, Newton said there are particles. Now I say we see that it doesn't work. I say there is a big wave function. But I still think I can go locally and consider all possible measurement and to say there is a complete local description which tells me probabilities for outcomes if what want to work. There is a local description here. And this is given that I know everything. It's not I'm not relative to any kind of. So there is a complete description here.
Okay.
I can change if I believe in one word and if the measurement has an outcome. Then this description can be changed by action in space-like separated region, and this is action at a distance. And
So just to agree with you under the assumption that you make, if you assume the underlying framework in which you are, which is what you described, you have one universe, the proportional local, and the other. Okay, in this case, which is usually called the standard realism, you are right. We agree, but it is only because you have this underlying framework, which is the standard realism. And what you know is that many people don't agree with that, and that results in the fact that they don't agree with your conclusion. But if you accept your standard realist framework, you're right. I think the same. But this is precisely the point. Why accepting that, and many are refusing this framework? That's the point. So it's useless to discuss about the conclusion. The point is that the basic assumption that you make, if you make it, you're right. But many people disagree with that, and that's with the assumption, the initial assumption.
So if I understand correctly, if we can come to agreement, in a framework in which I can talk about action at a distance, then I have my point. There might be a framework which you cannot, there is no way to talk about action at a distance because one don't talk about local properties, and then there is no way to make this statement. Then I don't have my point. And if I can talk about local properties, and the change of local properties faster than light is action at a distance, then I have my point. But maybe we can, maybe cubists don't talk this way, or any other, Rovelli definitely don't talk this way. And then this is not applicable to Rovelli. But Rovelli is not kind of, okay.
Yeah. But
yes.
You're now saying, I think the objection from Philippe, if we phrase it in the language of sort of analytic philosophy of physics, is that you are now talking about property realism. You say you need to be a property realist to talk about real properties that are local. And Philippe, I think, was trying to accuse you to be an entity realist rather than a property realist. An entity realist, réaliste des entités, saying you don't just believe in properties, but for CSM, the only entity here is the pair itself. It doesn't consist of two different entities. There is one entity called the pair. Whereas for you, I think there are these local entities sitting there with properties that live together with them. And I'm not sure you have to be an entity realist. Maybe you can just be a property realist, and that's already enough for your argument. Maybe you don't have to be an entity realist as Philippe wants you to be. I mean, I don't agree with either of those interpretations, but that's my personal thing. It doesn't matter.
but maybe one more thing. I can say it was polarized electron. Now it's a polarized electron. This is language. I think it's more clear. But the real thing, why I think that no interpretation can, because I really can talk about operational meaning. There are some measurements here, and what I know about this measurement before, and what I know about this measurement after my action here, and this what I know about this. If I say that these operations and measurement here, they relate to here, not necessarily. It might be spin, whatever particle, I don't care. There is a machine. Give me some outcomes. And I have some probability distribution for complete knowledge about this probability distribution. I can change it by action here. And then I say if it's a one word, it changes. If it's many words, then no problem, because in one word it's up, in another word down. When you look on all words together, then nothing changed here. Again, in every word it does change. What I wanted to say is that in every word there is a change, and people, even with many worders, are unhappy about this change, and they try to do some other exercises, like, okay, so let's, they want local Bierbel like Bell, or they really want this Deutschheiden story, which is completely local, it's also separable. What?
What you said about just on the previous slide with this, where you use the pronoun I, right here, yes. So you just said if I know or I measure and so on. So if once again, if that I is the God, if that I has both knowledge of the EPR state and knowledge of local measurement results, then what you said is not complete, because if you know the EPR state, if I knows that the global state is EPR
Before.
from the beginning, before anything, then this knowledge, according to, let's say, CSM or whatever, then this knowledge somehow also produces all sorts of knowledge of the kind, if I measure on Alice's side and I observe whatever, then on the Bob's side it would not be random. All of these if-then conditions, because they're part of the state knowledge. If you know the global state, then you have all this knowledge of all the if-thens.
But again,
and so you can't say that it's completely random because you have the knowledge of if-thens.
The first element on the first electron is random because
the first is random.
No, but you have the if-thens. Yeah, right, of course.
But again, before my opening here, it's random there. I think people have to agree. Everyone should bet. Everyone, there is no any reason not to bet. You strongly disagree, but in which part I'm not sure which part you disagree. You agree that before looking at this, you should bet.
I completely disagree with the last but one line. The measurement on Earth make it change. Measurement on the Moon makes it immediate change on the Earth. I think there is no physical action from the Moon to the Earth.
Sure.
There are correlations, and that's all.
But
There
again,
is no physical action.
But again, the point is, we're talking about measurement here.
Yes.
And
But
before,
the measurement there does not affect the measurement here.
sure, but the point is,
So that there is
there are two conditions. This measurement might be performed when this closed, and this measurement might be performed when it's open. And then, if it's closed, then you should agree that this measurement has random outcome.
Yes, sure.
And when it's open, you should not agree, because in your word, it's not if I believe in one word. There is only outcome. It's either up or down. It's not random.
No, but to check that, you need two counters, one on the Moon and one on the Earth, and then you compare the measurement of the two counters, and you notice that there is correlation, and that's all. There is no action at a distance between the two.
to explain this correlation.
But again, you should be ready. We don't do it in the Moon. We do it in a laboratory here.
Unfortunately, I have just started this discussion.
Yeah.
I suggest to stop it and to move to the next slide.
Okay, so then because of this, for me, it's kind of non-locality, and I believe this was make Deutsch happy about this and introduce his strange Deutschheiden story with, and then it moved to Gilles Brassard and his student to this idea of parallel lives, which the idea, here there is a disagreement that something changed there, but it looks like it bothered them. They feel that something changed there, so they had to make some dramatic changes. So what they said that it's when I measured here, this is kind of here, and this is on the Moon. when I measured here, there are kind of creation 2 of them. And when they measured there are 2 of them. But really, they don't, although there is a clear correlation, which you agree with me, between red and red, they say this correlation doesn't exist kind of locally. Only when they come here, because there are these kind of indices locally. You write, I perform a measurement, I get up and I get down. But in addition, I have some additional degree of freedom, which puts green and red. And then, and the same here. And so everything is local, because everything happens just here. And there is no claim that in this world it's green. The claim is that when they come together, only green will talk to green and red will talk to red. So this that makes every story completely local, but you add additional degree of freedom, green and red, to resolve this non-locality. Because I say in this world it should be down, and this world should be up. They say no, there are all these many words and there is no connection. Only when they come, they kind of talk to each other, and because of they have this additional character, one don't see the other.
That's more boring than in written. This doesn't sound very written to me.
It's boring, yes.
It's boring.
Yes.
I don't know.
Or Fuchsian.
Oh,
Anyway, I don't.
maybe Fuchsian, yeah, but kind of neo-borean much more than in written.
And it's kind of
There is no correlation.
there is a paper by
Communication.
I think by him that he says why by Bedard, I think. Yeah, that how 20 years non-locality was solved and no one accepted it.
Not very convincing.
Yeah. So, okay, let's, yes, but it goes together, so future. What will happen to me? The point is, so this is a many world picture, this is a world where I live and I'm here, and then I know that I will perform a quantum experiment. I didn't check if there is internet here. In my homepage there is a connection to a quantum experiment. Everyone can split the word for free. Or if somebody has iPhone, there is $2 application for word splitting connected to, I think, some quantum random generator. I'm also parasitic on some quantum random generator. Before it was laboratory in Tel Aviv, but now it's dismantled, but I connected to some random generator on internet. So I can perform quantum experiment, and I can write word A, word B. I say I cannot, there is no sense in which what is the probability that I will be in A, what will happen to me that I will be in A or in B. Because I know I will be in all of them. And I think this is a many word interpretation you have to accept. It's not just many words, it's also splitting. I was here, and now will be in all of them, and there is no meaning whatsoever in which one particular I will be. Still, there are many worders who are trying by force to add something, or to play with semantics of philosophy or whatever, to say that there is a meaning to ask in which word will I be. No, I will be in all. And when I'm in all, it's not really I have to be, I cannot sit on 2 chairs. This is not, people don't sit on 2 chairs. I cannot talk about Lev Vaidman sitting on 2 chairs simultaneously. Some Tampadin sometimes is ready to think that if I have exactly the same mind, that it's the same me or something. For me, there is no way. So there is no sensible way to talk about my future, because my future will be many futures. There is a sensible way to talk about my past. There is only one particular word. And in this word, there is randomness. Because all quantum experiment was kind of, looks like randomness and looks like action at a distance. Because in the moment Alice measured here, something happened far away. Now, this action at a distance, in fact, is very small. Because for this I need entanglement. Entanglement is not, it's very difficult to make this entanglement. You need to spend a lot of effort to make. But in principle, you have a turbulent and you have this. So I think one to have to accept not to ask who will I be in the future, because I will be old. And this is kind of illegitimate question. And I think Wayne was kind of agreeing with me. I found one of his talks about 5 years ago. And no real sense in which I can have degrees of belief that says spin up will be the result. No real sense in which I can talk about the chances of outcomes. However, because when I'm here, in many words, you cannot ask what is the probability for an quantum measurement to be performed. All of them will happen. But it seems that it's many people are disturbed, especially Simon. I think he was with David. David maybe not there anymore, but at least in this paper that they say playing with some natural semantics that they are uncertain to the outcome. And the meaning that they're uncertain, but there is an outcome, that they can't talk about the outcome. I think you cannot talk about the outcome because all outcomes will happen. I didn't mention Wilson, I think, made a lot of ideas in this direction. This is very recent, last year. Probability is objective chance of centered propositions. The whole idea there is no probability in many words. Everything is completely deterministic. There is an illusion. When I'm going backward, if I'm looking backward in time, there is an illusion of probability. Because I remember all this quantum experiment, I can talk about it.
Right. How can you then make predictions? Because you probably will say you cannot, but isn't that the goal of physical theory then?
You remember there was discussion about this unitarity and Born rule.
Yeah.
So, in addition to unitarity, there is a postulate of a Born rule about that probability to find yourself in a particular world.
Okay. So you can talk about this with your extra postulate.
But also about just myself, not about physics. Physics evolves unitarily. But locally, I find myself as particular. There is some. Also, I have this concept about measure of existence. I know I can talk about this. In which way I say I will be in all of them, but they will have different measures of existence, and I care about them in proportion to their measure of existence. So my behavior will not be significantly different than everyone else. But the language is different. It's not. There is no probability of this or this. Everything will happen. All will happen. Some of them will happen with bigger or some with smaller. If I will arrange, they all will have equal measure of existence. It's just small equal combinatorics. I will bet in the same way on all of them. But if they have different, if I have one fat one, I will have to look how many I can split to get them equal, and then I will use.
But that seems to be in agreement with Everett himself, who said, all of them are equally real, except that there is this measure of me being, in this world or that world, as I observe some measurement result. This seems to be compatible with Everett.
I don't think I'm completely compatible with Everett. The only difference, and again, it's not really semantic difference, the way of preferring to talk about words. He talks about words relative to an observer. I prefer to make it more objective. In every word, all macroscopic objects should be well localized. So even some that perform experiment on the moon, the words split. But it's not. It's small difference and semantic difference. Everett is. I'm with Everett. I think my interpretation is Everett. It's easier for me. With Everett, hard to talk about times when there are no conscious observers, because there is no relative to him, to whom. But if there are still galaxies, exploded, not exploded, I can talk about macroscopic objects. So let's then maybe, okay. So, why the many world is not in the consensus yet? We are not happy to admit that we are not in the hub of the universe. We want the scientific explanation will tell us what we see is what is. We are not happy that we need some the Plato's cave idea that maybe the story is different and we have to connect our formalism like in special way, like I connect particular branches, the experience. We prefer that the theory will tell us what we see. We expect that ontology of scientific theory explains what we see without adding postulate of the correspondence between the ontology and our experience. We expect diachronic personal identity. It's hard for us to think that I cannot ask what will happen to me. We are not ready to accept that the question what will happen to me has no simple answer. And now I foresee that it will take some considerable time to change the paradigm of science to be satisfied with answers it can give. Because something, as other theories give answers, that many words doesn't. But maybe because these answers do not exist. So let's stop here.
Thank you very much. Any new other question?
Maybe about the most general presupposition you are making while you are defending the many worlds interpretation. You ask, for instance, the question of how does the formalism connect with experience? And because you want, so to speak, either a strict isomorphism between the formalism and experience, or a connection between them with a certain rule of connection. For instance, the bond rule can be one of these rules of connection. Now, one can completely revert the standpoint and start from experience and ask what is the formalism that allows our experience to project into the future. And this is completely different. You don't need any connection between the formalism and the experience because experience is the basis and formalism is a tool for the one who has experience. And this standpoint, I think, is typical of Cubism.
Yeah, that's Fuchs. Yeah, that's Fuchs.
Well, just let me tell you.
Not only Cubism.
First, will you say that?
If you experience
I agree with everything what you said except the last sentence.
Yes, because for you experience is not in first person. For Michel, experience is only in the first person.
No, for me, experience.
And for you, experience is shared.
I know that Chris Fuchs is sharply denies that his approach is shut up and calculate.
Not really.
What?
No.
He's trying to say
he denies.
He denies it.
No, that's not true.
What's true? What's not true?
That he's not a shut up and calculate guy.
He denies.
No.
But this is more or less what you tell me, that I have experience and I can calculate what experience I should expect.
No.
And this is what
Michel is talking about Husserlian phenomenology of experience.
Yes.
Yeah, I mean, Michel is really talking about Husserlian phenomenology of experience and its connection with the idea of scientific description.
Yes.
Yeah, and Fuchs has bought into that kind of recently, as we will hear in April. Fuchs is following Michel on this Husserlian interpretation.
Maybe just.
No, because it's first person only, so there's no connection with CSM. Because for you, the notion of experience.
But there is a connection, but it's quite different. They are members of a similar family.
You have to put your identity under epoche, which for Husserl is bizarre.
Yeah,
how can you do that?
Yeah.
May I just how I see it? I'm here on one branch. I have my experience. I have experience of one branch, and I want to explain my experience with the theory. So the theory which we tried, classical theory, doesn't work. Then there is a quantum theory, and people were reluctant very much. They tried to explain the empirical evidence with all kind of theories, but the theory which worked was quantum mechanics. And this quantum mechanics gives this picture. To avoid this picture, you need collapse, or just to say no, there is no underlying. There are all kind of relationals. There are all kind of other things. If you want the standard paradigm of science, which was understood in classical science, you want formalism, which explains your experience. There is no any difference between experience of standard quantum mechanics and many worlds. It's exactly the same empirical difference. The only difference is that in many worlds, the physics has no this unexplainable collapse. This is the only thing. So it's many worlds, it's standard quantum mechanics without collapse, with observation that we don't really see the evidence for collapse. There is no experiment, we don't have technology to test the collapse. So,
but we don't have the evidence for the other worlds either. So
what?
why should we don't have any evidence of the many worlds? You don't have evidence for collapse, and I don't have evidence for many
but
worlds.
Collapse is additional physical law. Why should I add it?
Because I need it.
No, no, you don't need
You
it.
implicitly need
You
it.
don't
have
need
a problem with the Born rule. So
No, you don't.
something
No,
that,
no. The Born rule I add, not
with collapse
collapse.
it's natural. Without
No.
without collapse, you have problems. But then it's more a question of taste, basically.
Taste, as I say, action at a distance and randomness.
Yeah.
We had this fights about action at a distance. Yes.
Yeah, maybe one last question, or at least. So, I was always struck by the role of memory in Everett. So, you haven't talked about thought experiments of the following kind, which I find very problematic for Everett. It's connected with the problem of diachronic identity. Imagine for a moment that I forgot who I am. So time flows, but I forgot who I am. And then 10 years from now, suddenly, can I remember again who I was or not? Like if you are in the future, then you don't have a memory record, right? You forgot. Can you reconstruct who you were or not? So this story of memory records somehow being very crucial to Everett, you see, has always disturbed me in a way. Because what happens if the observer, like if I forget my identity, which happens psychologically to people, right? I forget my identity and then 10 years from now, suddenly I remember again who I was. Is this something that can work with this branching story? I'm not sure.
I'm not sure how you can apply this. The question is, in particular branch here,
Yes.
there is enough information.
No, you probably have to start again. So you can never remember who you were. If your memory was erased, so if you forgot, you can never remember again who you were, right?
If I have a spin half particle and I measured spin in z direction,
Sure.
I have no way to know what it was before. I know it wasn't opposite to what I found. But what it was before, there is no way to know.
And now instead of talking about spin z particle, talk about I as you do in your talk, right? Because I is much more complicated than a spin z particle.
But again, in the spin, for example, if I also have memories that this particle came out of particular device, which prepares spin in particular direction. So even on the particle itself, I cannot know the memory, but looking on other devices, I can understand what was the state of the particle. So the question is how much information I have around. So it's the same about the personal identity.
Yeah, just
if
one
I
last
find
thing.
my uncle or my aunt, she will tell me what happened to me.
Yeah,
And this is kind of real situation.
I mean, we can talk about it later. So one last phrase and then I stop. I think the only way out of this is to say that if memory is erased, worlds end or worlds get erased, because I don't see how else you can get out of this.
So there is one case when it's a kind of I can arrange Wigner friend. If I have super technology, I can split the world and then bring them together. This requires erasing of memory. I cannot
Yeah.
can link together without erasing memory, because otherwise it will not come to
You
one
will not
word.
come together.
So, but then again, if I know all the devices before, I can prepare the machinery which will split me and bring me back, and then I will look on all this machinery. I will know that I was in two words and now I'm again in one. There is no any contradiction with this situation. Or it's not practical. No, it's not something practical, but conceptually. In laboratory, always this is what we do with photons. We split them then in two different arms of the interferometer, and then tuning properly. Now I bring it only to one arm. There were two words. My first paper on many words, schizophrenic experience of a neutron, why we should believe in many word interpretation. I really discussed this kind of situation. You split a neutron on a crystal 10 centimeters, so 5 centimeters apart, and then you bring them back. And then because I kind of can do a Wigner-Friend experiment for a neutron. So if I attend consciousness to a neutron, I can do this thing.
So worlds do end.
What?
Worlds do end. If they bring them back, in a sense, there were two, now there's one.
Correct.
They end. Yeah. So yeah, that was definitely not in the original Everett.
I think Everett was.
I think it was.
It was.
It is not. It is not in the wit.
It's not in the wit.
It is not in the wit, but
Okay,
it is in the original Everett.
Okay, I agree with that.
Yeah.
It's not in
Yeah.
the wit. Yeah.
Yeah.
Okay, I agree with that. Yeah, maybe it was an Everett.
Yes.
Well,
Merci beaucoup, Lev. Thank you very much, Lev. And we had a very good discussion. It was good. Thank you very much.
Thank you.